In this section, we want to look at constructing linear models that will allow us to answer questions about real-world problems. The first example we want to look at deals with linear population growth. If a town's population has been decreasing at a constant rate, in 2019 the population was 5,238 people. By 2023 the population had dropped to 2,753 people. Assume that trend continues. And since we're told that that rate of decrease is constant, that's a key to us that this is a linear situation. What we want to do is start off by using Symbolab to construct a function p of the year t that models this scenario. That is, we want to construct a line through the 2 points that were given. To do that, we'll set up a line through our 2 points. So our first year is 2019. And we have our population in that year, and then our second year that we're given is 2023 and the corresponding population. We can construct that model. In this case, Symbolab is giving us output in fraction form, exact form. If we want to convert those to decimal values, we can do that by going back to our entry field and type in those literal fractions that were given. And we'll get a decimal approximation for each of those values. We can do the same thing with the second value. And what we'll come up with is the equation p of t is equal to negative 621.25 t plus 1,259,541.75. Once we have that model, then we can use Symbolab to predict the population of the town in 2027. To do that, we'll enter this equation that we constructed. And ask Symbolab to evaluate that for t equals 2027. And we get a value of 268. Meaning that in the year 2027, if this model holds, the population of the town would be equal to 268 people. And then in part C, we want to predict the year in which the town's population will hit 0. That means that what we want to do is set our population model equal to 0 and ask Symbolab to solve that equation. It doesn't like what I typed in. So let's try that again. It's not recognizing my input correctly here, so what I'm going to do is just retype this entire expression because there's something in there it doesn't like. It might have been that I did this out of order. So we'll ask it to solve negative 621.25 t plus 1,259,541.75 set equal to 0. And I liked it when I typed it in that way better, so we get a value of t equals 2,027.43138. We're given the direction of the problem to round that answer up to the nearest year, so we'll round that up to the year 2028. Our model predicts that in the year 2028, the population of this town will hit 0, assuming this model is valid and that same relationship continues to hold.